Welcome to this explainer. Today we're diving straight into what is essentially a high-stakes scientific detective story. We're going to unpack a groundbreaking new climate study straight from the Potsdam Institute for Climate Impact Research, or PIK for short. And let me tell you, what these researchers have uncovered, it fundamentally changes our understanding of the current pace of climate change. It's all about finding the true signal hidden within a whole lot of complex noise.
So the big question right out of the gate is simply this: is global warming actually speeding up? I mean, you've probably stepped outside over the last couple of years, felt that intense, globally recognized heat, and wondered exactly that. Well, the central mystery these researchers wanted to solve was whether this extreme heat is just a temporary spike, a fleeting blip on the radar, or if it represents a permanent, structural speed up in how fast our planet is actually warming.
To really set the stage for this investigation, we have to start with the cold, hard facts, or I guess in this case, the hot facts. 2023 and 2024 definitively rank as the two warmest years since we started keeping instrumental measurements way back in 1880. So your personal experience of the recent heat, it's entirely validated by the data. The baseline temperature of the Earth has been unusually high. But, and this is a big but, having a couple of record-breaking years doesn't automatically mean the underlying rate of warming has permanently accelerated. Figuring that out requires a much deeper look.
Which brings us to part one, the global warming speed-up. When you look at the overall timeline of our planet's warming, there is a really stark contrast between two distinct periods. The researchers looked at the historical warming rate from 1970 all the way through to 2015, and then they compared it to the rate of warming from around 2015 to the present. What they identified wasn't just a slight bump. Actually, scratch that. It was a distinct, statistically significant rise in the pace of warming that kicked in right around that 2013 to 2015 window. The trend line essentially steepened right before our eyes.
To put that into perspective, historically, so from 1970 to 2015, the Earth was warming at an average increase of just under 0.2 degrees Celsius per decade. But during this past decade, that rate has jumped to an estimated 0.35 degrees Celsius per decade. That means the rate has nearly doubled. We are literally looking at the fastest warming observed in any decade since temperature records began in 1880. It's an absolutely massive leap. So how did scientists actually figure this out with so much certainty?
That leads us to the next step, filtering out natural climate noise.
To truly see the long-term trend, we have to wrap our heads around natural climate variability. Basically, these are short-term natural events that temporarily raise or lower global temperatures. They create a ton of noise in the data, making it incredibly hard to see what's actually happening underneath. Enter U.S. statistics expert and study co-author Grant Foster. He and his team essentially had to act like forensic detectives. They needed to systematically scrub away these distracting short-term natural influences so that the true underlying long-term warming signal could finally become visible. To build their case, the researchers systematically removed the influence of specific suspects. We're talking about things like El Niño events, volcanic eruptions, and natural variations in solar activity, like the recent solar maximum. What's absolutely fascinating is that when you adjust the data to account for these natural factors, the extremely warm years of 2023 and 2024 actually appear slightly cooler in the analysis. Yet even with those corrections, they still rank as the two warmest years on record. By removing the noise of El Niño and solar cycles, the underlying accelerated warming signal became undeniable.
Now that the noise has been cleared away, let's look at part three, a statistically certain shift.
The absolutely crucial takeaway here comes down to one massive number, 98%. PIK researcher and lead author of the study, Stefan Ramsdorf, along with his team, established a 98% statistical certainty that this acceleration is real. This isn't a guess, it isn't just some rough hypothesis. With the adjusted data, the acceleration of global warming since 2015 is a mathematical near certainty.
Now, to achieve that 98% certainty, the team applied some pretty heavy math. Specifically, a quadratic trend analysis and a piecewise linear model. While the jargon is complex, these statistical techniques served one very precise purpose: to evaluate whether the warming rate had changed since the 1970s and to pinpoint exactly when the shift occurred. It's important to note that the study focused strictly on determining that the pace changed and when it changed, showing the shift starting around 2013 or 2014, rather than trying to model the specific atmosphere causes behind why it happened.
And to prove this wasn't just a fluke in one single computer model, the researchers analyzed measurement data from 5 completely independent, widely used global temperature datasets: NASA, NOAA, HADCRUT, Berkeley Earth, and ERA5. Across all 5 of these datasets, totally independent of the analysis method chosen, the result was exactly the same. The faster warming trend is consistent across the board. The math is rock solid. We have the data, we have the certainty, and we have the timeline. But what does this actually mean for us in the real world?
That brings us to our final section, the 2030 climate deadline.
The authors of the study issue a pretty stark warning. They point out that if this newly discovered, accelerated pace of 0.35 degrees Celsius per decade continues, it completely alters our immediate future. Specifically, we are on track to exceed the Paris Agreement's 1.5 degrees Celsius climate limit before the year 2030. The window is closing, and it's closing much faster than historical data previously suggested.
But ultimately, what happens next is still in our hands. Lead author Stefan Rahmstorff notes that while climate models already allowed for the possibility of an increasing warming rate, the eventual outcome depends entirely on our actions. He says, how quickly the Earth continues to warm ultimately depends on how rapidly we reduce global CO2 emissions from fossil fuels to zero. It's a powerful reminder. While the math shows we are definitely speeding up, the brakes are still something we control. So how fast can we hit zero emissions? That is the ultimate question we're left to answer. Thank you so much for joining me for this explainer, and as always, keep questioning the science around you.